All right, ladies and gentlemen, this is going to be fun. This is one of those days where you get to do something that really is secretly easy, but makes you look super duper smart. We are going to solve, which is your jam. You guys are really good at solving, so that'll help. The only thing that makes it fancy is we're going to be solving trigonometric equations. So, what we're going to do is just solve by getting the trig function alone, so the sine, the cosine, or the tangent. Then you can just kind of treat that part like the x, like you would have back when you started to learn solving. You might need to factor. Oops, now my dogs are going to bark. And you may need to square root. Remember, if you do that, you have to do plus minus. Hey, Cinder, we're having school. And then the key and the only difference is that you're going to use the unit circle to find the values for x that make the trig statement true. So we're going to just solve like usual. And at the very end, the only thing that is genuinely new is going to be looking up our options on the unit circle. So we'll take a run at this and see how far we get without having the dogs bark. Alrighty. So we're going to give our answers in both radians and degrees to practice that, which really means we're going to get double the number of answers because, for example, if I get 30 degrees as one of my options, I would also have to write that as pi 6, which is not a new answer. It's just the other way of measuring that. All right, so what I could do, like this problem looks really confusing, but I can think about it as like 2y minus 1 equals 0, and then it's not confusing anymore. If I know how to solve that, which you should, you'd add the 1 and divide by 2 in order to solve for y. You'd end up with 2y equals 1, y equals 1 half. It's really no different. So over here, I'm trying to isolate this, just like it says up here. You're trying to get the trig function alone. So I would add the 1 to the other side. Then I would divide by 2. And so now I have a problem like we were practicing before, which is where is the sine value, which remember that's y, where is the sine value equal to 1 half? So this is the point where I go ahead and use my unit circle. This is the only new part. I start looking around the unit circle, and the more I know this, like the better I know this unit circle, the easier this will be for me. Here's the first place that I see a y value of 1 half. So ironically, my little example earlier is that x could be 30 degrees or pi over 6. Those are not two different answers. They're just degree and radian for that specific spot. The other place that I have a y or sine value of 1 half is over here. And so that is going to be 150 degrees or 5 pi over 6. And so I've got all my options for x in both radians and degrees. There will not always be the same number of answers. Sometimes you have more, sometimes you have less, depending on how you went about it. Okay, so again, if you need to, you could think about number 2 as 1 minus 2y equals 0, where your y is taking the place of the cosine x. And you can solve it that way, or you can be brave and just know that this is your variable, the cosine x, and you're trying to get that alone and tackle it directly. So then I'd take away the 1. Don't drop that negative yet. So I've got this equals negative 1. Now I'm going to divide both sides by negative 2. So I end up with cosine x equals positive 1 half. Now keep in mind you're going to get a lot of the same numbers because we're using the unit circle. And it seems like a lot of numbers on the unit circle, but there's a lot of repetition. So here I'm looking for the cosine to be a half. So now I'm looking for the x value to be 1 half on my unit circle. And again, the more I know this, the quicker I can say, here's an x value of 1 half, which is at 60 degrees, otherwise known as pi thirds radians. Excuse me. And another place that my cosine, which is x, would be a positive 1 half is right down here. So that is going to be another answer option, which is 300 degrees or 5 pi thirds. So there's other places where the x is a half, but it's negative. And so in my case right now, that's not an option. So those are my two options for this question. All right, so let's take a look here. Again, think of this as a y plus 1 equals negative y. When you're solving, you need all the variables together. So we have to move them all to the same side. And you can do that a couple of ways. If you decided to take this away, don't think these cancel out because they don't. You end up with 1 equals -2 sine x. And then I'm still trying to get the sine x alone. That's my variable. So I'm going to divide by -2. So I end up with the sine of x equals -1/2. Go to my unit circle and find the place where the sine or the y value is equal to -1/2. And my sine or y is equal to -1/2 right here. I can see that. And that's at 330 in degrees, or 11 pi over 6 in radians. Isn't this fun? And then another spot where my y is -1/2 is over here, and that's going to be at 210 degrees, or 7 pi over 6. So you want to make sure you work on these worksheets in front of your brothers and sisters and parents because they're going to think you're really smart. This one's tricky. So think about y squared minus y equals 0. One of the things up here that was mentioned is that you might need to factor. That is pretty common. When you have an x squared or in your equation, you'll either need to factor or square root to solve it. In this case, a square root sign won't work because I also have a plain version of that same variable. So if I think about how I would have tackled this, I would have factored out the greatest common factor because remember you call this the gotta check first. So you always want to look for what do they have in common. Obviously they have a y in common. So I would end up with these two factors and then I could solve for my options. Well, it's no different over here. These two have a cosine x in common. This was squared, so I'd still have 1 left. Here, if I divided out a cosine, I'd be left with a 1. And then the way these work, if you remember, is I have to look at this and think, what makes cosine x equal 0? And here, for this entire factor to be 0, the cosine value would have to be a 1. That way I'd have 1 minus 1 and I would get the 0 that I'm trying to get. So now is the time for me to go to my unit circle and find where on the unit circle is the cosine value 0, keeping in mind that's my x coordinate. So my x coordinate is 0 right up here at the top, which we call 90 degrees or pi halves. My x coordinate is also 0 at the very bottom, which is going to be 270 degrees or 3 pi halves. That is what this one contributes for options, but I also have this factor. So now I go to the unit circle to see where are my x coordinates, meaning the cosine, equal to 1. Well, I have a coordinate right here of 1 at x, and so that would be 0 or 360. And in radians, that's still 0 or 2 pi. Now, there are no other places where the cosine's 1 because over here the cosine is -1, and that's not what we're looking for. So in this case, I ended up with a couple extra answers because of the method of method of solving I had to use when I factored. All right, let's get to the grand finale. And of course, the ones that need the most space, I have the least space, so that's awesome. This again would be similar to 2y squared plus 3 equals 4. Now this one has a square in it, and there's not a plain y, so I can solve this one using square roots ultimately. But to do that, I need to get this alone. So I'm going to take away a 3. So if I take that 3 away from both sides, I'll end up with a 1. Then I need to get rid of the 2 by division, so I'd end up with a 1/2. You can't go to the unit circle yet, though, because you don't have this plane. You have this squared. So I'll need to square root both sides, introducing that plus or minus. That's what this is talking about up here. So now I'm going to have the square root of sine squared, which is just sine. So that side was easy peasy. Over here, keep in mind the square root of 1 is just going to be 1. But then I end up with a radical 2 on the bottom, and I need to rationalize that because we're in honors math class. So I end up with positive or negative root 2 over 2 as the sine value. So I'm going to my unit circle now, and I'm looking for a sign value, which would be the y coordinate, and it can be positive or negative root 2 over 2. So again, that's why I was kind of preaching to learn the unit circle, and the reason I've been doing the go formatives, I know that all my root 2 over 2 values are in these middle marks. So as I travel around the unit circle, the first thing I see is this one has a y coordinate of root 2 over 2, so I'm going to be at 45 degrees or pi fourths. I continue to the next middle mark. I'm looking for a y coordinate of either positive or negative root 2 over 2, so this qualifies. So that's going to be 135 or 3 pi over fourths. But again, because I had the plus minus option, I can also use these where my y is a negative root 2 over 2 on the bottom. So that's going to be at 5 pi over fourths, or 225. And lastly, right here in quadrant 4, I have another spot where my y is negative root 2 over 2. And that's going to be at 7 pi over 4, which is equivalent to 315 degrees. So just kind of cramming that all in here to leave room for number 6. All of those answers give me places on the unit circle where the sign value is positive or negative, root 2 over 2. So all of those would satisfy this equation. All right, last. I know you know how to do this now. You're probably already done. I'm going to need to get this part alone again, and I can see it's squared, and I don't have a plane cosine, so I'm not going to be factoring. I'll be using the square root. So I'm going to add my 5 to both sides. So if I add it here and here, I have 4 cosine squared equals 3. I'm dividing by my 4. And now I'm going to introduce a square root sign, plus or minus. This will turn into regular cosine of x. I forgot the variable up here. Oopsies. And then here, the square root of 3 I have to leave because it's not a perfect square, but on the bottom, the square root of 4 is a 2. So I am good to go to the unit circle because I'm looking for the places where the cosine of the angle is equal to either positive or negative root 3 over 2. So I'm looking for x coordinates to have that value. So if I go to my unit circle, looking at x coordinates, the first place I see that as my x value is at 30 degrees or pi 6. The next place I see that root 3 over 2 as an x coordinate is right over here. And it doesn't matter that it's negative because I had to do plus or minus. So that's going to be at 150 or 5 pi over 6. I keep trucking around the circle. Right here I have another place where the x coordinate or cosine is negative root 3 over 2. That's at 7 pi over 6, which is 210 degrees. And then lastly, if I keep going over here, I have an x coordinate and therefore cosine value of root 3 over 2. And that is at 330 degrees or 11 pi over 6. So all of these are options, even though these two are the same and so on, because I'm just writing it like I said, it says in the directions to find all the answers in radians and degrees. So now you have a worksheet to work on. They're going to be exactly the same kind of layout. Think about what we learned today for day 1. And make sure, again, that you work on your worksheet in front of a lot of people because you're going to look super duper smart. Have a great day, you guys. Bye.